source IP address would be 1.1.1.1. The destination IP address would be 5.5.5.5. And the layer 2 information, for example, the layer 2 address of R2's interface here, and R2 using the layer 2 address of R3, the layer 2 encapsulation isn't going to change either, because those layer 2 addresses really are going to be the same between R1 and R2 and between R2 and R3 respectively. But what is going to change is we are going to inject when we're doing MPLS, and I call it layer 2.5, right there. We are going to inject labels into the protocol stack. So what would happen at layer 2.5, as I like to call it, so as R1 prepares to forward a packet to 5555, it's going to know that R2 is its next hop. It's also going to know the label associated with 5555 coming from R2, and what's going to happen is we are going to inject or impose a label. In this case, the packet leaving R1 would have a label of 203, because that's the local label that R2 has associated with that network. Now at this point, the question is, okay, Keith, great. All I see that happened is we basically added layer 2.5 with an MPLS label to this packet that's being sent to R2. Now, how is that really going to help us? And here's the answer. When R2 receives that data, it's going to de-encapsulate the layer 2 information, and it's going to say, oh my goodness, it's for me. That's my layer 2 address. And then it's going to take a look at the MPLS label at what I like to call layer 2.5, and as it sees the label of 203, it's going to say, oh, I know exactly what to do with that. It has a label forwarding table that says, oh, if you get a packet that has label 203, go ahead and simply swap out that label with label 303 and forward it to your good buddy R3. And the magic is, and this is important, it never had to look at layer 3 information. It did not have to look at the layer 3 IP address. Now, what does R3 do when it sees this packet come in? Well, it de-encapsulates layer 2, sees its own layer 2 MAC address, processes the frame, looks at the layer 2.5, sees label 303, and it's also going to have forwarding information based on the label distribution protocol. So let's say, for example, that R4 had label 403. So R3 is going to perform something called a swap. It's going to remove the old label 303, it's going to put on the new label 403, and be forwarded over to R4. So as we look at the chain of events here, the packet at point A had a label of 203. The packet at point B is going to have the label of 303. So the old label got removed, the new label got put on, and then once R3 receives it, it's going to take off that old label of 303, put on the new label of 403, and forward it over to R4. And that, my friends, is the essence of multi-protocol label switching. And I want to come back to the point of, okay, so why does this really matter? Again, about a decade or more ago, using label switching was a lot faster than doing an IP lookup at every hop along the path. So a long time ago, it was developed primarily for speed. However, today, in the 21st century, we have some very advanced caching mechanisms, and we have a lot of really powerful hardware-based forwarding that we can use. So MPLS, all by itself, really doesn't give us a bang for the buck. However, there is some magic involved that you definitely want to be aware of, and that's this. Because R2 and R3 and R4 did not have to look at the layer 3 information, my question is, what could we send across an MPLS network if we're not looking at the layer 3 information? So let's say, for example, that this core network that we have is all running IPv4, and we have MPLS added to it. And let's say in our core network we have 250 routers. And then we have a customer who says, you know what, I need IPv6 connectivity between site 1 and site 2. Can you help me? Now we have a couple choices. Number one, we could say, well, I guess we could implement IPv6 across every device in our core. Or, check this out, because the core network never had to look at that layer 3 information, we could actually carry IPv6 traffic across an IPv4 network. Because all of these routers, they're simply doing label switching. They're forwarding based on that MPLS label information, and they're not forwarding based on the layer 3 information because they're not even looking at it. We could effectively tunnel lots of different types of traffic across our network.
On top of
I remember an engineer telling me that
network.
MPLS paths, which are also referred to as
questions
LSPs,
for this video. Take a moment, read
label
these 3
switch
questions,
paths.
and if you know the
label
answers
switch
and are
paths are
comfortable
so
with
cool
each of the
because you
topics,
could actually
hey,
send
I'll see you in the next video. For everybody else, we're going to take a look at how to both implement and verify that MPLS is working. Let's begin.
I'd like you to consider something with me just for a moment. Let's think about all the people on the earth right now who, at this very moment, might be preparing and starting to learn MPLS and MPLS applications, such as Layer 3 VPNs. Now, out of that group, whatever that number is, how many of those people studying MPLS are going to become really good at
decisions?
And the
based
answer
on
is
other
about
than
5 to 10% of people who study some topic are going to rise to the top of their field.
Let's begin.
So, for example,
all right,
maybe
my
this
friend,
person,
here are the
maybe that
opt-out
person,
questions
or
for
very
this
likely it
video.
could be
So
you.
pause the screen.
And it's no
read these three
accident
questions.
how
If
these
you know the
individuals,
answers
including
to these and
yourself,
are
are going to
comfortable
get
with those concepts,
very
hey,
competent
jump to the next video.
at the
I'll see you
technology.
there.
And that, my friend,
For everybody
is
else,
through
we are going to have a great
hands-on
time
practice.
right here.
And that's why
Let's
in this
begin.
course,
I'd
if
like
you'll be
you to
willing,
imagine in
I'd
your
like to
mind
set
that
you up for success
Tuesday
by
afternoon
sharing with
we
you
just
how you
had a
can set up
great
your
lunch,
own
and as we're
lab.
walking
And then
back
as we
into
go
our
through the videos
offices,
together,
we get
in
stopped
this
by a
course,
manager who says,
you can
"Do you have a
pause me
moment?
as
Could you
often as
explain to me how
practice
IP
right
forwarding works?"
alongside of me. And what's
As
our
we
answer going to
implement
be?
MPLS
Absolutely
and
yes.
the
We
MPLS
would love
applications
to
that make
walk
it
you
so
through that
desirable.
process.
So
here's
the first thing we
ingredients
want to do
list
is
I'd
make
like you
sure
to
we
put
understand
together
where we're
as we
starting with our
create
manager.
your own
Now,
private
if our
lab
manager
environment
already
that you can
knew
practice on.
about the basic
First of all, we're going to start with
concept of
GNS3.
an
Now, I'm
IP
using
address,
0.8.6.
that an IP address has two
and if you're
components
using a
to it.
more
There's a
current
network
version
portion
like
and a
version
host address portion.
1.0,
Starting
or
from there,
version
we say, you know what,
1.x,
let's say that
it'll
this
have
router,
the similar
R5,
functionality
has
that
the
you
IP
need
address
to
of
practice the MPLS.
5.5.5.5.
The second thing
Maybe
you're
that's
going
a
to need
loopback
if you're
address
using GNS3
sitting
is
on
some
R5.
type of an iOS
And it's been
operating
advertised
system
inside
image
of a routing
that
protocol so that the
supports
entire
features
network
of MPLS.
knows how to reach 5.5.5.5.
And the iOS image I'm using in GNS3
If an administrator sitting at R1 did a ping request
with
over
the
to
advanced IP
5.5.5.5,
services feature set,
it would go something
and you don't
like
have
this.
to use that exact model of hardware. And you don't have to use this exact flavor of iOS as long as it supports the protocols we're going to use in class, primarily MPLS. You should be fine. You could also be running iOS 12.x or 15.x. That also is not going to have any significant impact on what we're going to be doing in this course. So if you do have an iOS image and you're not sure whether or not it supports MPLS, there's a couple ways to figure that out. Number one, we could just try to implement MPLS on it. And if the commands don't take, that's a good indicator that it doesn't have those features. Or secondly, you could use the feature navigator up at Cisco, put your version of